Matrix multiplication is one of the very few skills that you'll need to be able to do by hand in this topic. And what we need to know first, before we even start to do a calculation, is whether or not the multiplication is actually defined. So if the multiplication is not defined, then there's really no need to waste time trying to calculate something that doesn't exist. So if you can do a quick check first, you can save yourself some time and effort. So first thing you need to understand is that for multiplication of matrices to be defined, the number of columns in the first matrix has to be equal to the number of rows in the second matrix. So we can do a quick check before we start doing a calculation just to see if it's worth the effort. So in this first example, we've got a 3 by 2 matrix, and I'm trying to multiply that by a 3 by 2 matrix. So the order of both of those matrices is the same. I'd be able to add them or subtract them, but I need to do a quick test to see if I can multiply them. So the number of columns in the first one and the number of rows in the second one are not the same. So straight away I can say I'm not going to even bother to put that into a calculator or try and do a calculation by hand. Because those two numbers are not the same, the matrix multiplication is not defined. So when you tried to calculate that one, if you were to put that into the calculator, it will say something about a dimension mismatch or a dimension error, and it just doesn't exist. So in the second example, you can see we've got a 2 by 2 matrix multiplied by another 2 by 2 matrix. So again, the order of both of those matrices is the same. So I could add them, I could subtract them. And now if I look at the number of columns in the first one and the number of rows in the second one is the same, so I know that the multiplication is defined, so I can do that calculation. So it is worth persevering with this one. And the interesting thing about it is that the two numbers that are left over tell me what the size of the answer matrix would look like. So I know, without even doing this calculation, before I start, number one, the multiplication is defined, so I can get an answer. And number two, I know what the answer is going to look like. So let's do a couple of examples of this type. So we've already tested with this one that I know that the multiplication is defined. The number of columns in this one is the same as the number of rows in this one. So I know that multiplication works, and I know that the answer is going to look like a 2 by 2 matrix. So when I'm doing this kind of calculation, the two words I like to use are run and dive. So as we're doing this, we're going to be running across one matrix and diving down the other matrix. Okay, so I know the answer to this matrix is a 2 by 2 matrix. 4 elements in this matrix. So in order to do this, I'll try and color code this so that you'll see where I'm going with each run and each dive. So to get the answer, which is in the first row and the first column, I need to run across the first row and dive down the second column, the first column. So I'm going to be doing the calculation 1 times 5 and 2 times 7. To get a different color, for this element here, which is in the first row and the second column, means I'm going to have to run across the first row and dive down the second column. First row, second column, first row, second column. So I'm going to do the calculation 1 times 6 and 2 times 8. Figure out our next element, so we'll colour this one blue. And this particular element is in the second row and the first column. So to do the calculation, I need to go across, run across the second row, dive down the first column. Second row, first column, second row, first column. So the calculation is 3 times 5 and 4 times 7. And our final element is in the second row and the second column. So I need to run across the second row and dive down the second column. The calculation is 3 times 6 and 4 times 8. So now it just becomes a simplification now. 5 plus 14, 6 plus 16, 15 plus 28, 43 I think, and then 18 plus 32. So my answer looks how I suspected it would look, but quite a complicated calculation to get to the final answer. So it's very easy, and you can see I've color-coded when I was doing it, and I say first row, second column, first row, whatever I'm doing, and calculate accordingly. If we have a try at a different looking problem, first thing I need to do is to test can it be done. Is the multiplication defined? So our first matrix is a 1 by 2 matrix. My second matrix is a 2 by 1 matrix. So I check the number of columns in the first one, the number of rows in the second one, so I know this multiplication is defined. And I know this time my answer is going to be a 1 by 1 matrix. So I'm expecting a matrix with one number in it as an answer. So this time when I'm doing my calculation, because I've only got one answer, I'm looking for first row, first column. So in this example, I'm going to run across the first row, dive down the first column, and my answer calculation will be 1 times 3 and 2 times 4. 3 plus 8, 11, which is a 1 by 1 matrix. Keep trying. If I was to switch the orders around of those two matrices and try this one is a 2 by 1 and this second one is a 1 by 2, I look at the number of columns in the first matrix, the number of rows in the second matrix, so I know that can be done. My two leftover numbers tell me the size of my answer, so I know my answer is going to be a 2 by 2 matrix. So I sort of know what I'm looking for, what I'm expecting. So I know that my answer this time is going to have 4 elements in it. It's a 2 by 2 matrix. And each one of my rows and columns this time only has one element in it. So if I'm looking for first row, first column, I run across the first row, down the first column. 1 times 3. To get my second element, which is in the first row and the second column, run across the first row, dive down the second column. 1 times 4. So the calculation is a little bit easier this time because there's less bits and pieces involved. So in this third element, second row, first column. Run across the second row, dive down the first column. 2 times 3. And then our fourth element is in the second row and the second column. So run across the second row, dive down the second column, 2 times 4. So in this case, my final answer will be 3, 4, 6, and 8.